بسم الله الرحمن الرحيم. أبنائي وبناتي طلاب الصف الثالث الثانوي، بنكمل مع بعض حل أسئلة يونت 1 لسون 1 كتاب المعاصر. السؤال رقم 13. If the work done to transfer a quantity of electric charges 5 coulomb يبقى أعطاني الكيو. Each 1 second يبقى أعطاني time. Between 2 points in a conductor is 100 joule يبقى كده أعطاني الwork done. Then the potential difference between the 2 points equals. أنا عارف إن potential difference V equal W over Q. طيب ال W عندي 100 جول والQ عندي 5 كولوم، يبقى 100 over 5 equal 20 وات جول بير كولوم or volts. يبقى أنا قدرت أجيب البوتنشال ديفرنس 20 والأنسر letter D. نروح للسؤال اللي بعده. بيقول لي the following electric current intensity through the conductor equals. أنا عشان أجيب الإلكتريك current I equal Q over T. طب أنا عندي ال Q 5 كولوم وال T 1 second، يبقى 5 over 1 equal 5 أمبير. عندي 5 أمبير، يبقى دي الإجابة الصحيحة. نروح للسؤال الثالث. The number of electrons that pass between the 2 points through 2 seconds. طيب أنا عندي عايز number of electrons. أنا عارف إن ال I equals Q over T، صح كده؟ وال Q دي equal NE over T. معنى كده إن ال I اللي أنا جبته من شوية equal NE over T. طب تعالى كده نعمل كروس الاي في التي، الاي في التي equals ان اي، صح كده؟ الاي في التي equal ان اي. انا عايز نمبر اوف الكترون، عايز الان، يبقى اقسم هنا على الاي واقسم هنا على الاي. الاي راحت مع الاي، يتبقى لي الان بتساوي اي تي اوفر اي، وهو عاطيني هنا التشارج اوف الكترون 1.6 times 10 باور نيجاتيف 19. ببساطه يبقى الان بتساوي الاي، انا حسبته من شويه 5 امبير تايمز التي، الزمن هنا عايز الزمن ايه 2 سكند، صح كده؟ اوفر الاي 1.6 تايمز 10 باور نيجاتيف 19. الاقي عندي الان بيساوي كام لو استخدمت الكالكوليتر؟ بيساوي 6.25 تايمز 10 باور 19. وبكده حليت السؤال 13 كاملا. تعال نروح نشوف السؤال رقم 14. In which of the following cases the arrow represents the correct direction of the electric current through the resistance between the 2 points A and B. A B A B A B. طيب أنا عارف الإلكتريك كارنت بيتحرك من الهاي فولتج لإيه؟ لللو فولتج. فتعالى هنا من 10 فولتج ادي الالكتريك كارنت دايركشن لل 2 فولتج، يبقى من الهاي فولتج لللو فولتج، يبقى الاجابه دي صحيحه. الاقي الكلام هنا ما ينفعش من شايف الارو من الزيرو لل 10، يبقى ما ينفعش. الاقي هنا الارو من نيجاتيف 4 لبوزيتيف 2، يبقى ما ينفعش. الاقي هنا الارو من نيجاتيف 4 لزيرو، يبقى ما ينفعش. يبقى الاجابه الصحيحه من الهاي فولتج لللو فولتج الالكتريك كارنت بيتحرك. وبكده حلينا السؤال رقم 14. نكمل مع بعض، نروح للسؤال نمبر 15. In which of the following cases the intensity of the current that passes in resistor R is greater than the other. طيب انا عندي فولتج وعندي ريزيستنس، وزي ما انت شايف الريزيستنس هنا الفولتج اللي بيتغير 1 فولت 2 3 4 فولتس، تمام؟ طب هو القانون اللي بيحكمني ايه؟ اومز لو، اي ايكوال في اوفر ار. الار كونستانت زي ما انت شايف، ار ما اتغيرتش. ايه اللي بيتغير؟ 1 فولت 2 فولت 3 فولت 4 فولتس. يبقى النيوميريتور هو اللي بيتغير والدينومينيتور ثابت. صح كده constant. يبقى الهاير numerator الهاير voltage يبقى higher current, higher intensity of the current. يبقى بالتأكيد الإجابة الأخيرة هي الصحيحة. So let's go to number 16. Each of the following diagrams represents a part of an electric circuit. Then in which of them the ammeter and the voltmeter are correctly connected such that the resistance of resistor R can be determined using their readings. You have to know ابن الطالب بنت الطالبة, you have to know that ammeter is connected series and voltmeter it measures the potential difference between 2 points, so it connects parallel. Okay, so here ammeter connected right series, but voltmeter connected series also, so it is wrong. Here voltmeter is connected series, it must be connected parallel, so this is wrong. Here the ammeter is connected series right and the voltmeter connected parallel to measure the potential difference between 2 points, so C is right. And the last one is wrong because ammeter must be connected in series, not parallel. So let's go to last question here in this page. A potential of difference of 12 volt, so you have V, is applied between the terminals of a conductor to move 6.25 times 10 power 18 electron. So if you multiply this number times the charge of electron, you will get the quantity of charges in coulomb through a cross section of this conductor within 2 seconds. Then the resistance of the conductor. So you know well that I equals Q over T, right? And in same time it equals V over R, right? At the beginning, let's calculate the I, or we can use instead of Q NE over T equals V over R, right guys? So let's at the beginning calculate, or we can make it in one step. What we need now, we need R. So cross R N E equals VT. So what do you need? You need R. So divide by NE here and there in both sides. So NE, so R now is alone equals V 12 volt times T, what is the time, 2 seconds, over N, the number of electrons, 6.25 times 10 power 18, times the electric charge, 1.6 times 10 power negative 19. Use your calculator and get the answers. You will get the answer equals 24 ohm. Try it, guys. Try it and use the calculator. I make it in one step. You can, at the beginning, get I alone, and after getting I, use Ohm's law, I equal V over R. If you will get I alone, you will reach that the electric current intensity equals 0.5 ampere, and use it. In Ohm's law, 0.5 equal V over I, so you can, R equal V over I, so V 12 over I 0.5, so you will get the same answer, 24 ohms. Let's move to the next page. Number 18, an electric bulb of resistance 1.6 ohms, so you have the resistance, is connected to 9 volts battery, so you have the voltage or potential difference. So the number of electrons here in this problem needs the number of electrons that pass through a cross section of the bulb's filament every minute. So now you have the time. Look carefully, the time here in minutes. You must convert it into seconds, so 1 minute equals 60 seconds. So you know well that I equals Q over T, right? Or NE over T, right, guys? So from this relation, you can get that NE equals IT, right, guys? So N, you need N, guys. So divide by what? E, and here E. So from this relation, N equal IT over E. But you don't have I, right, guys? So let's stop here and do something. Use Ohm's law, right, guys? So NE equals, instead of I, you know well that it equals V over R times T, right? So you need to get the number of electron, divide by E, and here divide by E. So now you can get the answer. N equals VT over RE. N equals V is 9 volt, T is 60 seconds, right? R is 1.6 times the charge of 1 electron, 1.6 times 10 power negative 19. Here 1.6, this is the resistance, and this is the charge of 1 electron. If you are using your calculator right now, you will get this answer, 2.1 times 10 power 21 electrons. I hope it is easy, guys. Let's move to next problem. Number 19. A conductor of resistance 10 ohm. So you have the resistance, carries an electric current of intensity. You have I. Okay, if an electric current of intensity, so this is I1 and this is I2, pass through the same conductor at constant temperature. Hold on, same conductor at constant temperature. So the resistance is the same. The resistance constant. Resistance doesn't depend on the current that move. Here he asks you its resistance right now when the current increase or double, the same resistance. The resistance that gave it in the problem 10 ohm, so it is 10 ohm. Hold on, the resistance is the same for the same conductor at same temperature. Doesn't it change? If the current is it changing, the voltage is it changing from Ohm's law, but the resistance is depending on the length and the cross-section area and also the type of the material. You know this law, R equals rho L over A. The area is the same and same material at same temperature, so the resistance is the same. Let's move to next one, number 20. The opposite graph represents the relation between the potential difference across each of the two wires, A and B. So you have two wires, A and B, separately, and the current intensity that is passing in each of them. Then which of the two wires has a higher resistance? Here in the graph you have the relation between voltage and the currents. So if you want to get the slope, R equal V over I, this is the slope, right? When the voltage increase, current increase, resistance is constant, right? The resistance of a material A, RA, and RB. As you see, the slope represent the resistance, right? The slope represents the resistance. The sharper slope, the sharper the resistance, because the slope represents here the resistance. Let's see the choices. The wire of the higher resistance. A, because the slope of the line represents the resistance. This is the right answer, guys. This is the right answer. Because as you see, the slope, y-axis over x-axis, represent the resistance of the line, represent the resistance. And from the graph, you can see that the slope of A is larger than the slope of B. Got it? Tan the angle here in A larger than tan angle here in B. Okay? The problem is if he use I instead of V or V instead of I. We will see a problem like that later, inshallah. Let's go to the last one here in this page. The opposite electric circuit. What in the opposite electric circuit, what is the factor that should be increased? What is the factor you must increase in order to increase the current? You know well that V equal IR. Right, guys? Here is variable voltage, DC source. So you can change the volt, and also you can change the resistance. If you increase the resistance, the current will decrease. Right, guys? So you must increase the voltage, right? You must increase the voltage to increase the current, because I equal V over R. If you increasing the voltage, the numerator, the current will increase. The voltage means the electromotive force of the battery that you are using. So to increase, what you must increase to increase the current? The electromotive force of the battery. So letter A is right. The length of the connecting wire is wrong, because if you increase the length, the resistance will increase, and this is decreases the current. The resistance which is taken from R, if you increase the resistance, as we said, the current decreases. The temperature of the resistance. Hold on. The relation between temperature and resistance, you will know it later. If you increase the resistance, the temperature, also the resistance will increase. So you must choose letter A, and let's go to next page. Number 22, in the opposite circuit, which of the following graphs represents the relation between the reading of the ammeter, the intensity of the current, and the value of resistance, which is taken from RV. As you see, the battery, its electromotive force or voltage is constant. So V equals IR. As you see, the relation between the current and the resistance, if you increase the resistance, the current decreases. Right, guys? Because the electromotive force is constant. So inversely proportional between the reading of the ammeter and reading of and the current that moving. So this is inversely relation. As you see, here is ammeter reading and RV. If you increase the resistance using the rheostat, تمام, what will happen? The current decreases, inversely proportional. So this is right. The relation between the current moving and resistance is inversely proportional. Let's go to next relation. The reading of the voltmeter and the value of the resistance, which is taken from RV. Okay, the value of the resistance. The potential difference, as we said, doesn't change. It doesn't depend on the resistance. The current depends on the resistance. So the reading of voltmeter and RV, the rheostat, the reading of the voltmeter is constant always. So the answer is D. Let's go to the next. Here, the reading of the ammeter and the reading of voltmeter when the value of the resistance which is taken from RV changes. Do you remember that we said in the last question that the reading of voltmeter doesn't change? The reading of the electromotive force is constant, so it doesn't change. What is it changing? When the resistance it changes, the reading of the ammeter, not the reading of the voltmeter. So the answer is letter D. The last problem here in this page, electric power and electric energy. Hold on. What is the power? The work consumed in a specific time. We can use this definition to get the work P equal W over T. This is one definition for work. Here he asks you about which of the following isn't equivalent to what. Hold on. Work in joule and time in second, joule over second, it yields watt. Okay? So it works. We need that one is not equivalent to watt. Let's see the other relation for the power. P in electricity, P equal IV. I in ampere and V in volts. So AV is another unit for power. So this one, it is equivalent to what? Let's see something else. You know well that P equal IV, and from Ohm's law V equal IR. So P equals I times IR equals I square R. I square means ampere square times ohm. So this one is equivalent to what? So the answer must be the last one. Let's see this relation. P equals I times V, but you know well that I equal V over R, right? So P equals, instead of I we use V over R times V equal V square over R. V square means volt square over ohm. And this is right and this one is wrong. That's enough for this video. God save all of you, my kids. Let's move to the next video. لا إله إلا أنت سبحانك إني كنت من الظالمين. كان معاكم مستر إبراهيم سلطان Physics and Chemistry teacher.